So by request, I'm going to take a little bit more look at file input-output, talk through the code that's necessary. There was a lot of confusion about exactly what we were doing here. To make this really simple, what we want to do is, if you haven't noticed, in your computer, you've got random access memory, and if you've ever kicked the computer power cord while you were working on a program and hadn't saved it, you know that everything you were working on just disappears. So when you run a program and then you exit the program, you want to make sure that the data that you were working on is still there when you come back at a later time. So if you think about Microsoft Office, you save out files as a Microsoft Word document. In our case, we don't want to get as complex as, say, a Photoshop document or a Microsoft Word document, but we're used to this idea of saving our work to a file, and then we're able to open that file and work with it later. In Java, there's a really simple way of managing this process using the file input-output methods that are built into the system. Now, a couple other things we could use. I mean, obviously, we could define our own customized data format, like Microsoft has done with the Word document format. We could use an XML document. We could actually go ahead and use a database, something like really big, like Oracle, or really tiny, like there's even little Java SQL servers that that you can embed into your programs. In our case, we don't want any of that overhead. We're just going to use some simple text files, and we'll look at how we can actually mess with those. But in this case, let's walk through everything we need. The functionality to read from and write to a text file is not included by default in the Java namespace that we're normally given. So in this case, I need to import two sets of functionality. I'm importing java.util. Notice I'm importing everything in that namespace. That'll give me the scanner functionality. I'm also importing everything in the java.io namespace, and that'll give me my ability to write output to a file. And then, it basically just gives me access to all of the classes that have been written by some microsystems to allow me to have this functionality, so I don't have to write it myself. This is the name on lines 4 and 5 of my whole program. I jump down into my main method. The one thing that seems a little bit unique to everybody is this new addition to the end of our main method called throws file not found exception. So one of the things you should know when you're working with an external file, it's very possible that you could go to read an external file and the file wouldn't be there. And so what this is Java's way of handling this exceptional case where you've hard-coded the name of a file and the file cannot be found. And an exception, you'll notice throws. Think of baseball. In this case, file not found exception would be like a baseball, and the program is going to throw it. Who catches it? In this case, the computer catches it. So if the file isn't found, an error will be reported to the system, and in this case, it'll crash our program. So, why are we doing this? In this class, we don't talk too much about exceptions, but what you need to know is that Java has the ability to warn you of exceptional situations, and sometimes we can respond to those. How do you know what's an exceptional situation? In this class, I'll tell you. Moving forward, you'll learn to read the API better and find those things out on your own. You'll even know how to write your own exceptions so that you can have the computer warn you of differing exceptional situations. So the only difference here to my main method is that after the second set of closing parentheses in the condition, but before the opening curly bracket, since we're focusing on formatting, is that I'm going to throw a file not found exception. So if I can't find the file I want to write to, it'll tell me. It's kind of a nice feature. Now I'm going to set up some variables. The whole idea here in my program is I'm going to ask my end user to enter some values, and I'm going to take those values that they entered, and I'm going to write them to a text file. Now, how do you get a text file, by the way? A bunch of people were confused. In JGrasp, we can go to File, New, and we can choose either a Java file or a plain text file. So if I wanted to, I could actually set up a data file. If I wanted to have a class list, I could have, Jason Wirtz, pick on Brad Pitt, Ryan Howard, whatever, right? And what I could do is I could actually put each person's name on a separate line. The way to imagine a text file is it's a blank canvas. If I wanted to, I could actually organize my file like this, where I know that the first item is a person's first name, the second item is their last name, and then when I get to item 3, so you almost think of it like every odd item in the file is a first name, and every even number item in the file is a last name. Or what I could do is I could put each person's name on their own line. Think of this kind of like a simple spreadsheet. You have the right and the ability to format an input plain text file any way you want. It's really up to you. In our case, we're only going to have one simple piece of information put into our text file, and we'll see that in a bit. So we're not actually creating a text file to read in from yet. We're just going to write to one. So in the case of writing to an external text file, I don't even need to create one. Okay, because I'm going to have my code create that file for me on the hard drive. Obviously, you need the right permissions to be able to write to the hard drive. So first thing I'm going to do is set up a scanner. This is a traditional scanner, and it's going to allow me to stop the program and in my input box down here, ask the user to enter some values. What am I going to store in those values? First name, last name. Oops, we'll get rid of age. I was playing with this a little bit before. All right, so I set up that object. It's a scanner object. Remember, a scanner object is this friendly little piece of code that stops our program and lets us read data in from the user from the keyboard without any real work. I've called it user input. So anytime I need to do work, I'm going to ask the user input object to do work for me. The next object that I need is the ability to write output to a file. Notice I've commented out my in file because we'll work on that in the second half of this lecture. So I'm going to go through and I'm going to set up a print writer object named outFile. And anytime I need to write something to my output file, I'm going to ask the outFile object to do the work for me. Over here, I've just hard-coded the name of my file. If we wanted to, we could actually ask the user what the external file name should be, and maybe we can do that modification real quick when we're done. So I'm going to set this up like a typical scanner. I'm going to say user input dot next because I want to get a first name, and that's going to be a string, and I'm going to store that into fname. And down here I want to get a last name, so I'm going to do lname. Oops, and there's capital N's in there, or I already made that mistake once. So notice I make spelling mistakes too. Everybody does in your code. It's very common. And I'm going to enter the age, and at this point we'll just read it in as an int. Don't have to read it in as an int, by the way. I can just leave it as a string, but I'll choose to keep my data types correct. So now as my program runs, it's going to execute top to bottom. It's going to set up some storage locations, set up a scanner object so I can read data in from the console. It's also going to set up a print writer object so I can write data out to an external file. We're going to prompt the user to enter some info, store it into our variables. Then finally what we do down here is we are going to go ahead and write our data to the text file. And notice I'm using println, so it'll put one piece of data on a line. And then when I'm done, I need to close. And what this does is flush the output buffer. To save, to get efficiency on your hard drive, when you save something, it doesn't always directly save it to disk. Usually what happens is your computer waits till it has a bunch of stuff to save to disk, and so it buffers the information, and then until it has enough information, then it writes it to disk. So if you've ever ejected a USB disk drive, one of the things you'll notice is that if you just pull the disk out, you'll get like this complaint, like the computer says disk not put away safely. And what it's saying is it might have had some data waiting in memory to write to that disk. It just hadn't done that yet. So the whole process of ejecting a USB disk actually takes this data that could be stored in RAM and forces it to be written to disk so that everything is on the disk and you can eject it. So here's our process. Set up our objects to allow us to write to disk. Set up our objects to allow us to get data from the end user, store that data from the end user into some variables, and then write those variables out to the file. And just to show you, I haven't run this yet. I'm going to look at the folder and notice there's no file called myoutput.out in this directory. So let's go ahead and run my program. And I'll try to make this fairly big so you can see it and you guys have the code to walk along with me. So I'm going to compile it and I'm going to run it. So I'm going to enter my first name, enter my last name, enter my age, and now my program exits. And you say, well, what happened? I didn't see any output. Well, guess what? All of my output was redirected to my out file, which was defined by my out file object. So I output everything to this external file. And now if I refresh this directory and come over here, you'll notice I now have a file called my output, and there's my output. That file was created by the Java runtime system. And notice that my first name went on the first line because it was printed there here. My last name went on the second line because it was printed there here. And my age was printed on the third line because it was printed there. Now, what if I don't want all those on one line? Well, I could make these print statements. Now what it's going to do is print my name right across a single line. Notice that I'm going to leave this file here in the directory. I'm just going to recompile and rerun it. So I'm going to enter my name again, enter my age again. Now my output.out file was overwritten. And now look at what happened, because I switched from using println to just print. So it actually put all of these on the same line. So how you organize your file is up to you, but this is basically just directing output to a file. So let's make this a little bit different. Let's copy one of these. And what we're going to do is print out We're going to look at how we can take our print writer and name the file. Enter the name of the file to create. And we'll make another string variable. We'll call it user defined out file. How's that? I'll copy that because it's really long. And because, now notice that code executes top down, so I need to ask for the file name before I can open the print writer file. So I'm going to move this line of code because I want everything to operate in the proper order. So now when my program runs, it's going to create my input scanner object. It's going to come down here and ask the user to enter the name of the file to create. I'm going to store that in user-defined output, and then I'm going to create my print writer. Oops. And I'm going to use that variable that contains the string of the file that the user entered. And now when I enter this data, it'll write it to my custom-defined file. So I'm going to compile it, and let's run it and see what happens. So now it says, please enter the name of the file to create. I'm going to enter my cool file .out or DAT. We'll stick with DAT for data. It's an old DOS term. Hit enter, and then it's going to create my print writer using that file name. Then it asks me for my name, and I'll say J Wertz. I can't spell. I'm close to 36, so we'll switch to that. And now if I come over here, this created the file that, and there's my cool file.dat, and it printed everything into that file. So this is a way to ask the user to input the output. So a couple other things that we want to do too is look at how do we read input from a file. So let's switch these back to println. And we already have a file. I'm going to concatenate some stuff here to each one of these. And again, I'm trying to do this lecture quick, so I'm not setting this up for really any edits. So that's why there's a little bit longer and a little bit more of me just mumbling a bit. So what I'm going to do is, let's do a save as. And we'll call this file io2. And then I just have to go up here and reconcile my name and my class. That was what the complaint was about. And now what I'm going to do is, I'm going to read my data in, and I'm going to read it in from the my output. Well, let's make a new file over here. Let's create a new file. Yeah, let's create a new text file. So let's create a file. And in this file, we're going to put three things. Stop using my name. It doesn't work. We'll put Apple, Microsoft, Google. I'm going to save it. We'll call it mydata.dat. Now I've got that file. So I'm going to read my file in from mydata.dat. So now what I'm going to do is I'm going to set up my scanner object. I'm going to set up an in file. This is going to go to the hard drive, and it's going to read the mydata.dat file. Which hopefully, yeah. Alright, it's weird. It showed up as a Java file, but it's fine. And scanner in file is going to set this up, and it's going to open that file and read it in. Then I'm going to ask the user to enter their output file, just like I did before. But now, instead of reading the data in from the user, what I'm going to do is I'm actually going to just read the data from that external file. So there's not a lot to this. I mean, it's really just looking at the code that's in the book and applying the code in the situations. Like, it's very straightforward when you need to use things. I have this input scanner because I'm going to ask the user to enter the name of the output file to create. I've hard-coded the name of my input file. And then what I'm going to do is ask the user to enter the name of their output file, just like we did in the last question, or the last piece of code. I'm going to go ahead and I'm going to set up that output file. I'm going to read the information in from my input file, all right, and I'm going to use InFile to do all this. I'm going to store those items into the appropriate variables. And now instead of age, by the way, instead of we'll do C1, C2, and C3 because we'll have 3 companies to read in. Let's get rid of age, don't need it. And we'll make this C1, C2. And I think there's also some advantage to watching me code. Not that I'm the world's best coder, but you guys can scrub through this as you see fit. So now notice InFile, it's going to read that information from the mydata.dat file, store it in these variables, then it's going to print it out to my out file, and it's going to add the output information. And what I'm going to do is flush the InFile buffer too. I mean, just it really just cleans up memory to get things going. So let's go ahead, compile this. Oh, and I forgot the in part. So there's, again, notice I make typos. Oh, and again, you'll notice I still make typos, which is fine. This is, again, hopefully a somewhat useful exercise for you. I want to do this with minimal edits so I can get this up to the discussion board quickly. Notice I can't type. Notice there's a good example of an error I made. I named outFile with a lowercase f and InFile with an uppercase f, which is actually a really bad thing for me to do. I'm not going to change it now because it would be a little bit of a pain in the neck, but notice that I shouldn't do that. So I'm going to run it. Everything happens in the order that we see it happening in. I run the program. It asks me what I want to create for my output. So I'm going to name it my new modified output.out file. It tells me that it's reading in the first item, reading in the second item, reading in the third item, so you can see where those items are actually read into. If I come over here, I can expand on that. And again, I read this in from mydata.dat. So we can look at that file. So it read Apple, Microsoft, Google. We can move this off to the side. And it wrote that to my new modified output.out file. So I'm going to bring that in. And notice that what it output was it read the data from this file and then wrote it to this file. And it concatenated the word modified. So you can see how we can read data in from one file, we can write data out to another file. Once you get used to this concept, we can start to format the data in unique ways. There's ways that we can read just a certain amount of bytes from a text file. This becomes actually really powerful. Things like the bank account example that I gave you for the midterm project. One of the things that's bad about that is you're storing someone's bank account in a text file. Like anybody can come along and edit a text file in any way that they want. Notice I can simply edit this. So it's too easy for a human to make changes to the text file. But in any case, it's a simple way of storing data. The next time we run the program, whatever we save to this file, it's saved to the hard drive. Anything you save to the hard drive exists the next time you come back unless your hard drive crashes. So it's a convenient way for data to carry over from one session of an application to another. Later on, you can play around with databases. You can use web stores for data, like online, Amazon has S3. There are people who use web-based databases. You can put data anywhere, but this is kind of the start to how do you save data. Would this be great for a word processor? No. Is this cool for some high scores in a video game? Sure. Is this a quick way to save some information about your model car collection? Probably. And then there's some more creative ways we can actually play with this data. We may or may not get a chance to look at some of those this semester. But one of the things to check out might be comma-separated value files. You're basically imitating, in my case, like I'm kind of imitating a spreadsheet, right? I've got rows. And if I want to, I could treat the spaces like separators, and technically this would be like columns. So you can start to imagine creatively how you can use text files.